This is lecture 8. Welcome back. At the end of the last lecture, I believe when I was talking about the vasa recta surrounding a particular type of nephron, I may have used the term juxtaglomerular nephron. And if that's the case, just make a note right now that there is no juxtaglomerular nephron, and that a vasa recta, a capillary system called a vasa recta, as we talked about before, surrounds a juxtamedullary nephron. Okay, so with that then, let's go back now to page 786 and look at figure 20.20. And on your lecture outline then, we're looking at these three main processes that are involved in urine formation. So go back, take a look for just a minute now at these three different processes. And so find the color-coded arrows indicating glomerular filtration. This will be way off to the left, material coming out of the glomerulus. Then find the color-coded areas indicating tubular secretion. And so, for example, up along the top part of the diagram. And notice then that tubular secretion involves materials being secreted into the renal tubule, into the tubule of the glomerulus. So tubular secretion, again from the figure, materials being secreted into the tubule from a capillary. And again, make sure you're finding that on the figure. And then also on the figure in several different places, including up towards the very top part of the figure, find now a color-coded arrow that's indicating tubular reabsorption. And again, remember the keys to this color coding are down in the lower left-hand part of the diagram. So again, up at the top now, find the arrow indicating tubular reabsorption. Notice the direction the arrow is pointing, and you'll see then that with tubular reabsorption, materials are being taken out of the tubule and going into a capillary. And when we look then, back to your lecture outline, when we look at urinary excretion, we look at what is in the urine that's being formed as this filtrate makes its way through the tubule system. What's in the urine is going to be, first of all, what we have as a beginning material from glomerular filtration. And again, back to the diagram, find the glomerulus, and realize now that glomerular filtration, we're talking about blood plasma, as we've talked about before, blood plasma in glomerular filtration being filtered out of the glomerulus and into the surrounding capsule. And so now within the capsule, we have this filtrate, and again, the filtrate is going to make its way through the tubule system. And as it's making its way through that tubule system, material is going to be added by tubular secretion. Again, find the arrows indicating tubular secretion and make sure you're good with the fact that we're adding materials from the capillaries and we're adding materials to the filtrate as it moves through the tubule. So again, urinary excretion equals glomerular filtration plus tubular secretion. Back to your handout, back to the formula. And then again, notice we next have minus tubular reabsorption. And again, go back to the figure, just find one more time an area indicating tubular reabsorption, and realize that with tubular reabsorption, as we said a minute ago, materials are being taken back from, lost from the filtrate and going into a capillary. And so the net result then of these three processes is urinary excretion, what's finally there at the end of the pathway in terms of what makes up urine. If you think about this for a minute then, with tubular reabsorption, we're taking out of the filtrate good stuff, materials that we want to keep. And glucose would be a great example. So at the beginning of this process, the filtrate does include some glucose, and typically we want to keep that glucose. We don't want to lose it as urine, and that glucose then is reabsorbed. On the other hand, there are various waste products that we'll talk about within the bloodstream. And we want to, of course, get rid of these waste products. And we do this then by the process of tubular secretion. And one more time, just to make sure everyone's good, find now an arrow indicating tubular secretion, and notice that arrow is going from a capillary to the tubule. And again, we're getting rid of waste then. We're dumping into the filtrate to be lost as urine these various waste products from the blood. And back to your outline then, and the final product of these three processes, filtration, secretion, absorption, the final product of these three processes is urine. Talking now about glomerular filtration, and let's just go to the lecture outline and just run over those fill-ins that are there for you. So glomerular filtration, as we've said, filters water and small substances. So in other words, filters plasma out of the glomerulus and into the glomerular capsule or Bowman's capsule. This filtered liquid, again, is called glomerular filtrate. When this filtrate is formed, large molecules such as proteins remain behind in the glomerulus. And again, the glomerulus, just a reminder, is the capillary system within the capsule, within the glomerular capsule. And these proteins remain behind then because of their size. They're too big to squeeze out of, to be filtered out of, to be pushed out of the glomerulus. Compared to, back to your outline now, compared to, and here I suggest that you go ahead and cross out a few words because they're really not necessary to the discussion at the moment. So compared to, and then you can cross out the proximal / arteriolar end of, so cross those words out. And what we're saying now is compared to other capillaries throughout the body, glomerular capillaries are much more permeable to small molecules because of many tiny openings called fenestrae in their walls. And I haven't directed you to a figure here, but if you flip back several pages, you can find this shown in a diagram. From here, we're going to jump down now and notice under filtration pressure, after the fill-ins here, there's a formula. And that formula says net filtration equals, and so on. So this reference to a figure is not on your lecture outline, but I would like you to flip back to page 782, and I'll give you just a minute to do that. And then take a look at figure 20.16 in the lower left-hand corner. Just to orient everyone, in the upper left portion of the figure, notice we're seeing a glomerulus with its surrounding capsule. And notice now that we're taking just that small area indicated by the box, that little portion of the glomerulus, and we're enlarging it down to the lower right. Take a minute and find the direction of blood flow, and notice then that blood flow is proceeding from the upper left-hand corner through this section of the glomerulus, through this section of the capillary system, and is proceeding then to the upper right-hand part of the diagram. And let's take a look now at three different things. We're going to take a look first of all then at what's labeled glomerular hydrostatic pressure. And here you might want to make a note. We can simply call this blood pressure. So glomerular hydrostatic pressure, it's just the blood pressure within the glomerulus. And notice then that this glomerular blood pressure, this glomerular hydrostatic pressure, is forcing materials out of the glomerulus. It's forcing out, it's filtering out plasma, and within that plasma, as we've said, there are various small compounds, smaller molecules that are being forced out also. So glomerular hydrostatic pressure. If you now move to the right a bit, notice the next thing that's being labeled by an arrow here is plasma colloid osmotic pressure. And what's happening here, if you think about it, as the blood is flowing through this small section of glomerulus, and as plasma is leaving the bloodstream, and as small materials within the plasma are also leaving the bloodstream, remember we talked about the fact that large molecules, proteins in particular, are too big to be squeezed out of the glomerulus. And if you think about it now, what's happening is that the blood is becoming hypertonic to the fluid outside of the glomerulus. And it's becoming hypertonic. Hypertonic, remember, meaning has more dissolved stuff in it, or has more stuff in it. So again, picture this blood moving through this section of glomerulus. Smaller materials are being filtered out. Large proteins are remaining. And again, those remaining large proteins make the blood in the glomerulus, as that blood moves along, make it hypertonic to the material on the outside of the glomerulus. Hypertonic, again, meaning that there's more stuff in the blood. There is more, there are more proteins, in this case, in the blood. And we'll stop here and pick it up right at that point with lecture 9.